Hi, this is Tim and Joel. Welcome to Midwest Hunting and Outdoors by Two Dumbasses,
a podcast about the outdoors, hunting,
and being a steward of the land. Welcome to Midwest Hunting and Outdoors, tips and tricks. And we got a project going on here. I say we, I really mean Tim. Tim, why don't you talk about, I know you're super excited about and been trying to get this done for a while and get all the parts and ready to go. Let's talk through what you're accomplishing.
Okay, so we bought our property here, Joel, probably 5 years ago. And on this property, he's got a pond. It's a beautiful pond, but when you go up to it, it really had this smell or a stench to it. And the dog would go swimming in it, and that stench would be on him. And I was trying to figure out what caused that stench, so I went out and did a lot of research and found that that stench is really caused from stagnation of a pond. Since I'm a new property owner, I don't have a lot of the history on the pond, and so as I did that research, I didn't know how many springs it might have, etc. So as we did research, we found that stench was a good indicator of that stagnation, and that if you don't take care of it, eventually it'll kill your fish. And so with that stench, you have this, what's called, I'm going to call it muck at the bottom of the pond. It's created by biomatter, usually tree leaves, anything like that. And also, since it's stagnant, you have a lot of algae. And I'm no expert on different types of algae, but lots of different types of algae. And my pond was getting algae on it as well. And so I'll share some of my little dumbass learnings. I had a buddy of mine tell me, he was, just put some copper sulfate on that. It'll take care of that right in a hurry. So I did that for my first year, and sure enough, it took care of that. But then as I did more research, I also found that, hey, copper sulfate will work for a while, and then eventually you'll get a massive bloom, and that copper sulfate's not going to help you. And also, going back to, you're still not addressing the muck, right? The muck. And as I did some research, there's these organisms that's at the bottom of your pond that will actually eat that muck, but if they don't have any oxygen, they're not like activated. Think of like in a septic tank. You have these organisms or bacteria that basically eat that biomaterial. And so what you need to do in your pond is create an oxygenated environment to activate those bacteria or microorganisms to eat that muck. And in the process, you're basically adding more oxygen to your pond, which is healthy for your fish, and then you have less algae. So as I started to do research on systems, there's a whole range of systems. I looked at putting in a windmill. Windmills aren't cheap. They have their pros and cons from a maintenance perspective. So I'm trying to spend at least...
Now when you're talking windmill, you're talking a windmill with an air pump that pumps water and diffuses or produces electricity, or both, or...
Yeah, great question. So you can get a windmill to do either, right? So I could get a windmill to generate electricity to charge my batteries for my pump, or I could get a windmill with a diffuser. With the diffuser, and as it turns, it pumps that air into the pond. But those windmills, it can be pretty expensive. I've priced them at $2,000 plus. So I really wanted to do a solar generated system, and the systems I was seeing at the time were $3,000, $3,500 plus, and you had to buy them. You couldn't really. And I looked out on YouTube. I really didn't see anybody at the time that knew how to build a solar powered aeration system by themselves, ad hoc. So what you're going to see today is Tim's some Timology, I guess, some Timology of jerry rigging some things together that I believe is going to work. And here we are.
Awesome. Well, how about this? How about we go through your inventory of parts, kind of walk through what each one is going to do, and talk us through it.
All right. Talking through kind of the Timology of solar-powered aeration systems. The first thing I did is I needed a power system unit. So what I did is I bought a couple of 100-watt panels from Renogy. The thing I really liked about the Renogy is they were pretty inclusive. They were pretty highly rated. Some good comments on them. So that's what I did. 200-watt panels, which should be ample amount of energy or solar power. And we're going to come back to that in a second. And so here's what these panels look like at the front. They're rated for, I think these panels are rated for, I believe, baseball size hail, but don't quote me on that. The cool thing is they're reasonably priced. If something were to go wrong with them, you could easily repair them. So there's the controller on the back. And today we're going to start to assemble these. The other thing that's the brainchild of this is the pump. And I actually have, for my pond, I believe the pond's about 10 to 12 foot deep, and High Blow makes a large variation of pumps. This is actually a septic pump, but my pond's about 10 to 12, 14 feet deep. This pump should provide ample opportunity. It's all self-contained. The top of it is the filter, so you have to clean that out per the company's instructions. And it's all 110, draws the power of about a light bulb, so pretty important there. So I'm going to put out a lot of air, and all I'm doing is drawing energy for basically running a light. The next thing is pretty important, is getting yourself a battery or two. I actually probably went a little overkill. I got 2 batteries, but I'm kind of one of those more is better. So I got these at Harbor Freight. They're solar powered batteries. I think the reason the solar power, they won't have any memory to them, and they're reasonably cheap. So I can't even remember exactly what I paid for them, but I'll put that in the excerpts from our video once we publish this. So now going through, what does Renogy give you? Renogy gives you all the connector cables, and they give you a controller. The one thing that they do not give you is they do not give you fuses, and these might be a little bit of overkill, but I want to be safe. So I'm going to, when I connect these up, I want to make sure that I have like bus fuses, so that if anything overheats, I'm not going to create a fire. It's going to blow a fuse, and we're still good. So I went out and bought these. These were also from Renogy, but they're solar PV fuses. Lastly, is the inverter. So the inverter, and what I bought here is it's called a 1000A inverter. So it's rated for up to 1,000 watts, and as I told you, these panels are around 200 watts. But this inverter here should be ample amount of power. And I have a good friend of mine who's like a genius. We're going to meet a little bit later, electrician, Dennis McVeigh. And he relayed to me, I was telling him as I bought this, I said, hey, to buy the right thing. And Dennis basically said, he goes, imagine you have this BMW car and it's rated to go 170 miles an hour. It you're probably going to get 250, 300,000 miles out of that car. He goes, if you treat it right. And he goes, let's say I'm running that car at BMW at 170 miles per hour all the time. I never let it off. He goes, probably not going to last to the end of the life of that car from a mileage perspective. He goes, electrical components are pretty much the same way. So I have 200 watts, but it's rated for 1,000. So we're going to be cruising at around 35, 40 miles an hour all the time. That car, or in this case, this inverter, is going to last a long time. So think about that when you make your purchase. So, I mean, that's all it. I mean, so from a total cost perspective, everything I've got in, the high blow pump was probably $350. That was my most expensive unit. A couple of batteries, the panels. I think the panels were like $150 a piece at the time, and they fluctuate in price all the time. So I think I've got $1,000 all in, unassembled. And I think from an aeration system, you're going to be hard pressed for that size of a pond to find something that's going to run 24/7. And talking to Dennis, my electrician, he thinks with these two batteries I've got, without even the solar power, I've probably got anywhere from 250 to 500 hours, depending on how these batteries perform. So you could even make an argument, do I even really need the solar panels? But I'm really setting this up for the long run. And then also I'm going to have a pavilion that's not going to be too far away. And so my side thought is, if I want to bring electricity up from this system, I could. And that's the nice thing about this inverter is I can pull additional power from it and power up that pavilion. So that's what we're at so far.
So probably the first step to do before we start to assemble is what's our plan. And so Joel and I started to try to figure out, hey, what's going to be the best layout. And what we did is we kind of mimicked the solar system that I installed for my Schlage. And so what you see here is I have one main post and I have some sort of a support going out horizontally, and then I have another support post supporting the top of the solar panels. And you basically have these risers that go all the way across to support the panels. And so then it comes to the materials. What are you going to use for materials? And so what we've chosen to use is we're going to use some 2-inch tubular steel, maybe a little bit overkill. It's 1/4 inch thick, pretty darn heavy. And we're going to sink those into the ground. And then our cross risers are going to be 2x4 green treated lumber. The other thing that's really important is getting your angle right to the southern sky, because that's where you're going to maximize the amount of exposure from a sun perspective. I don't remember the exact percentage, but I believe it's something around 30 degrees, between 30 and 45 degrees, that you have to have that aimed at the southern sky to maximize your chargeability. Okay, so as we said, we needed to assemble these two solar panels. And so when you look at these Renogy's 100-watt panels, they're about 21 1/4 width a piece. And so what we're going to do next is we are going to measure a green treated piece of lumber, and what we're going to do is we're going to cut them and assemble them and assemble them together as one panel all the way across. And we'll probably, this is what we're going to do. We're going to go overkill again because I don't want to have any issues. I've always cheated things in the past, and then those end up being dumbass moments. So I'm going to go a little further, and what we're going to do is we're going to put one riser right here, another one here, and then another one here. This bottom one I'm going to leave open just from an accessibility to the controller for the solar panel. Well, we're at the first phase of our implementation. We've got these 200-watt Renogy solar panels, and what we've done is assembled these. We had to make some alternatives via our other plan, but we've got green treated wood cross timbers, if you will, and we, instead of going flush, we ended up cutting them a little short so that we could get our fingers in to assemble with the clamps provided by Renogy. And now we're ready for our next phase, which is really for pole insertion into the ground. We're down at the pond site now. We had these posts put in yesterday and we'll show that video here in a little bit. But we put these posts in. They're 10-foot posts, 2-inch angular steel, pretty solid, probably a little overkill. But they are 10-footers, 5 foot in the ground. So I'm not pouring any concrete, but as you can see, these babies they're pretty solid, and for no more than what we're going to put on them. We brought the solar panels down, so what we're going to do now is drill a couple holes in this iron and slap our wood support braces around them, and then what we're going to do is start to get our angle facing south on these solar panels. And then once we get these in, we'll have something to support. We'll then put to the angle that we want from a desired perspective, and we're going to aim for probably right around between 30 and 45 degrees, and we'll get that measurement to you at further in the video. And then we'll know how big or how long our bottom support braces need to be. So that's our next step. Give me a squirt. So as we're drilling, we're down about 2 inches, 3 inches. 3 inches from the top. We're going to do both the same, and then what we're doing, got a couple titanium bits, and then what we're doing is also squaring a little WD-40 in periodically to keep the lubrication going. Might need 3 bits the way this is going. We've got these the upper extension arms now fastened. We've got a 6-inch
carriage bolt going through. Now what we're going to do, and we've got this really snug, but what we're going to do is build a 34-inch lower extension arm so we can get to this angle facing south, and then then we move on to the next phase of our project. So Joel and I have put in the lower support arms. They're now in place, and just to kind of give you a little perspective, these are 6-inch carriage bolts that go across 2-inch tubular steel. This baby is solid. I mean, they're super solid. Joel and I were just talking about there could be a little bit of a gravity pull, but if you look over here, I'm going to have you bring the camera a little closer, Joel. Point down here, if you follow these lower extension arms, you can see that we've got these cock blocked with the 2x4, so it's pushing against that lower support arm, so that should stop it from going down. I may end up putting a 2x4 here just to support it just a little more, but from looking at it, I'm not sure that that's needed. Anyway, so this concludes our assembly of this solar panel station. The next step is we're going to have to build a box to house our batteries, our inverter, and it's kind of our control box to keep that away from bugs and varmints. And then the last step will be assembly from an electrical perspective.
Today we've got a real big day today with regards to with our project, but before, I've got a good friend of mine, Dennis McVeigh, who's here from the Council Bluffs area to help me out. Dennis, why don't you tell us a little bit about your background?
Been an electrician since 18, got into Union Hall, did all my education that way, and done everything from residential to industrial. Now I do automation controls for the University of Nebraska. We do all the energy management type stuff, solar, anything and everything we can do to cut power costs. I came out today to help Tim put together a solar panel for a pond aeration, and this afternoon we're playing around and building a containment box so we can put all the components in it and make it where it's going to get some air to breathe by so nothing will overheat for him.
And I know Dennis just told you about his background. I've been in food manufacturing, seen a lot of great electricians, and for sure Dennis is at the top of the electricians I've ever had the good fortune to know. So I'm fortunate to have Dennis here as a friend and helping me out here. So what we're going to do next is we're going to walk over to show you what we're doing to build this containment box. Let's first, Dennis, walk through the plans you kind of sketched out and where we're going with that from there. All right, Dennis, why don't you take us through your sketch here and what we're doing, and then we'll go over to the real-life model.
The solar panels are already mounted on some steel posts and some wood framing, so we're making a platform box to be up out of the snow and out of any of the rodent or rabbits that want to chew on anything, and we can get better ventilation and protection from any hailstorms that would come about. So we just took some quick measurements for our base and how I wanted with the sides. We're going to put cleats in it to hold the sides more sturdy for any wind and that come about. Here we're going to put this at an angle. We'll put screening down here so it acts like a chimney. The cooler air will come on in, heat rises, and we're going to have a screen vent that you probably see over here. We'll cut this down. We're going to put some screen on the back side of those louvers so that this whole side can breathe, so our batteries have plenty of air to cool off, and so does our inverter. On this, we just laid out on where we're going to have our opening. It's about the size of our box on the inside. We want to make sure we had plenty of air around things. Inverter, really spaced off, so we got air all the way around everything. on it. Like I said, we'll put holes in the bottom to screen it with hole saws. This will be our front screen. This pump here, the high blow, very nice pump. You only have to service it maybe twice a year. That's only cleaning the filter. There is no other maintenance on a high blow. They're well worth the money. We researched them this here draws maybe about a 75 watt bulb, is all this one will draw. And it has a 4.5 inch PSI on the head pressure, which you need to understand that when you put your tubing that sinks into the water, that you can only push air down so far for it to come up out. Just like reverse of pumping water up, we're pushing air down in order for it to come up. So this pump here will work out real good for Tim. We can go about 12 foot deep with this, and it should just be fine for it. And this is only one battery. We will have 2 batteries. And with this situation, we're doing 12 volts. So these here will be wired in parallel, not in series. In series, you're going to get 24 volts output. Our inverter's at 12 volt to 120. And everything will be fused and protected accordingly for our amp draw.
Got the box pretty much done. We've got a couple of long ass hinges that we're using. It looks like this on both sides. We had to make a few edits to that. It called for a couple screws down here, and they was going to be drilling right into the plywood, so we decided not to do that. And we drilled a couple holes up here, holes just as well. So we've got a bow here in our top of our roof. We knew that going in. It's treated plywood, and so we were going to put some halves in outside to try to suck it down, but we decided against that. So what we're going to do is just screw it into our cleats that we put in here previously, and that's going to help us hold this down tight. A little bit annoying. So Dennis, what are we doing next here electrically?
Next, we're going to start taking the equipment, putting it inside, the batteries, the pump, and we got everything drilled with holes for ventilation, screens over it. It's all glued in place, so the bugs and that will end up staying out, and just clean them out a couple times a year so the pump gets plenty of air without filling up the filter in it. Then we'll start wiring the solar panels to it and give it a test.
Now Dennis, you talked earlier, this is an inverter that we're going to be using, and you wanted to we're going to be putting this up on the wall, is that right?
Yeah, but we're going to space that off so that it doesn't overheat. We're going to space that off about 3/8 of an inch so it has a lot of air ventilation around them. So that all this is a heat sink to dissipate the heat. We're going to give it all it can get. You can tell that they got fan built into them and stuff, so they'll last a lot longer that way. And with this is a 1,000 watt inverter. We're not running near that. We got about 100 watts and figured that at 125% because it's going to run continuously. But that way, if you give yourself that much of a lien waiver, the heat sink will take care of it and you'll never burn it up. They'll just run forever.
So what we've got here, now what you see is we've got this inverter that's zooming in. You see those spacers, and we just used a couple of nuts for each of them to allow air. And this is the controller, and if you buy a Renogy solar panels, they provide you with a controller, and this one happens to be the Wanderer. Alright, what do we see in here, Dennis?
Off of one good battery, it's got 13 volts on it. It's showing that it's putting out 13.1 volts coming off the inverter, and it's giving you 120 volts worth of power ready to go to plug in the pump and go ahead and run just with a fully charged battery, just like if it was nighttime and the solar panel's not going to produce any more charging system for you.
Because it doesn't need any at this juncture.
It doesn't need any at this point. It'll just run off that battery.
Okay.
So what we got connected right now is your Wanderer solar charger that's connected to the batteries, and then the battery is also connected to the inverter. Next, we're going to hook up the solar panels so that what we got left in the sun is going to head and start charging the battery back up. Down to the lake, probably do that tomorrow.
So Dennis, I see you're wearing an Iowa shirt and Iowa State cap. Tell me about that.
Well, I got two friends that are pretty good to me, and one went to Iowa State. Hey, what can I say? That one's a Hawkeye fan, so, you know, support them both. That way one can't say I'm not supporting one versus the other.
All right, let's see what you got going on in here. So you're hooking, the controller's hooked up to the battery. Now what we're doing is hooking the battery cables to the solar panels. Is that correct?
Yes.
And so the solar panels acts as a trickle charger to the battery, right?
Yes.
And then the battery is going to the inverter, right?
That is correct.
And then the inverter turns it from, I'm dumb.
12 volt DC to 120 volt AC.
And then, so then that's what powers our pump.
Yes.
And so on the back side of the inverter, it's got a couple of plug-ins, regular outlets that we'll plug the pump into.
Yes, and they have an overcurrent protection device built into the inverter to protect that.
Okay, all right. Dennis.
All right, doing a test just with one panel being charging, coming into us.
So I'm going to come over there and show what you're looking at. So if you look at the controller, you'll see on the controller on the Wanderer controller, it's got a diagram that looks like the solar panel. So he's got the positive and negative hooked into that. Now he's got this Fluke, who's not a sponsor of ours, and it's showing 19.
It's putting out 19 volts without a load on it, and the battery is not hooked up, so there's no backfeed. I'm seeing what's coming out, and as you can tell, it's not powered up at all that way. I'll go back over here to this side, and without a battery load, it's not going to charge nothing because it doesn't see it. Next, I'm going to go ahead and hook up the battery to this, and it should produce out to charge a battery properly. Your charging system, like on the car, needs to go at least 13 to 14 volts on the output side to give you a good charge.
So, and that's a Fluke battery tester. What?
Oh, this is a multi-tester.
Multi-tester. What model's that?
This one is a T5-1000.
T5-1000. So now you're plugging in the battery, right?
Yes. And plug in the battery, so we start charging.
But since the battery's already charged, we should see it shouldn't be charging it.
It will charge it, and then when it reaches its max, it just lets it bypass. You got your
Photovoltaic, yep.
It's charging. It's showing that it is charging.
Yep.
Giving us a charge. We're going to charge a 13 volts coming off of it.
Okay.
With that, so now we're going to go ahead, hook up the battery
now we're
to
hooking
the inverter.
Okay.
Cause the power load. That's kicking in. It's reading. It's going to produce us 120. She's still giving us 13 volts output for charging the battery, so we're ahead. Now let's go ahead and just plug this pump in.
Now
Put a load on it.
So we're plugging that to the back of the inverter, right?
Yes. As you can tell with the dust blowing, she's running.
It's really not too loud.
No. And with that, right now, we got 12 volts with only one panel. But if we put the other panel in, she'll be up to 14 volts, still charging. Sun's going down on us, and that's with one battery. We'll have two batteries. These are 35 amp hour batteries, so we'll have 70 amp hours worth of use. When the sun goes down, with only 100 watts going, so it should get us through the night with no problem.
Excellent. So one other item, so we've shortened the cables. We've cut the cables on the other end. These plug in, there's a male and a female. There's really only one way to plug these in. With these types of cables, you just got to find the positive and the negative. And they'll plug in, and they plug right back into that controller that we saw inside the Wanderer controller. Alright, so what we got going on today is I bought some just regular sand. This one just happened to be by Quikrete, but it doesn't matter. We have a Matala. I've got a double head diffuser, and from all the things that I've read, I believe that high blow should have no problem powering this. The base of this diffuser basically has a place to where you fill it up with sand, and that becomes your weight that fits down above the muck in your pond. But that's the heavy weight, so when you go to drop it, it's going to drop like this, and it's up off the bottom. So that's the whole premise there. And then we'll hook up this hose. So what you're going to see I'm doing now is I'm just filling up this base. So we've got the base full of sand. So the next thing is we're going to take the diffuser. It's got threads right here. We're going to put Teflon tape on here to try to seal that up, and then that will be ready to go.
We got the fill full of sand. Used Teflon tape so the air can't leak out of the diffusers, and just to keep the chain, we decided to put a chain on this so we have a float up on top so we can always find it, pull it up, clean it. We decided to put a float that's going to be down in the water line just to keep that chain up off the diffusers, and then kind of keep it out of the way so things are more even, and that's a locator. And so the next thing is we're going to hook up the air hose to it, take it out in the pond, submerge it, and on top we're going to be building a float at the top so we can always locate it, pull it out.
And we got the SS Minnow over there that's going to make its maiden voyage into the pond. Alright, one other thing we're going to be doing is we're going to have a float that has a chain on the top of the pond, so that if I ever need to go find the diffuser, I have it. So what we've come up with is we're going to use roughly a 2-foot piece of 2-inch PVC. We're going to put a couple caps on it. We're going to put an eyelet on it so that it can float, and then you can find it at any time if I have to go and clean off the diffuser. And I will have to go and clean off the diffuser. So what you see here is we're going to use a little acetone to clean off the PVC. We've got our cement, and then we've got our caps here that we're going to use to put on the ends.
All this product is a surplus stuff that he's came upon on his property, and we're just resurplusing it, putting it to good use.
Yep, exactly. All right, Dennis, what are we doing here, pal?
We're hooking the float to our chain, just putting a little bit of extra safety in case if something wants to give away or rust away on us. Just putting a couple of tie wraps on the things so we can always have it.
Got our 5/8 of an inch internal dimension self-sinking hose. I bought 100 feet. I was thinking I'd only use 50 feet for this pond. Now thinking it's going to be 70 feet. So I'm glad I bought 100, and buying in increments of 100 is a lot cheaper anyway. So we've marked it off in 10-foot increments just to see where we're at here. Anything else? And then here's our buoy, our finished buoy. So now going into launch mode. So I'm going to go out there, and then I'm going to anchor off. Oh.
That is awesome. You guys see it from there?
I can see it. Can you see it?
I can see it.
You ought to smell the sulfur coming off.
Oh my God, I can smell it from here.
Well, as you can see, I'm sitting here looking at a Renogy 12 volt. It's a gel battery. It's that 100 AHs in the amp hours. And what you start to see here is I initially bought 2 solar powered batteries from Harbor Freight, and they're rated for 35 amp hours. But when you start to do the math, which is all new, but I'm starting to get it. When you start to do all the math, my pump's pulling about 1.5 amp hours. I lose about 20% of my amp hours just going through from batteries to the inverter, and from the controller I lose about 20%. So initially I bought the 2, as I stated, 2 batteries from Harbor Freight. One of them ended up bad. All the literature I've read is hey, if you're going to put a couple batteries in parallel, they need to be the same kind, otherwise you're going to damage your batteries. So I was going to go and buy another Harbor Freight, but that would have only been 70 amp hours total, and which was still not going to be enough. So I now have gone with the Renogy. There are a lot of different types out there, or brands I guess I should say, and types. And I decided to go with the Renogy brand. It's a gel. It's called a hybrid gel. It's a little more expensive. Well, actually quite a bit more expensive, but I only need 1 battery. I need 1 battery, and 1 battery should do everything I need it to do. So I've got it plugged in right now just with the 1 battery, and what you can see is hey, we're generating pretty good aeration off of the pond. The problem is with the 2 panels, I just can't keep it running enough, and now with the 2 panels in this Renogy brand battery, I should be able to run 24/7. Now, one other item, actually 2 other items. I bought a 100-foot of hose initially. I was going to cut it to length. I've decided against that because there might be a time to where I just want to move that rubber hose. I will bury it up until this coil, but I've decided how I'm not going to cut it in case I want to move it elsewhere in the pond. So that's why I haven't cut that. The other item is I have 2 panels here, and rather than try to jerry-rig something in, I didn't initially buy splices, but I did here. And what you'll notice is I have the splices put in to connect 2 panels into one to go into the controller. I also only have fuses on one of the panels. I've got the other fuses up in the house. I just haven't brought them down yet, but those are 30 amp fuses, and I'll have those all connected in so that we won't have any issues from a fire perspective, etc. It'll just blow the fuse like it's supposed to. So anyway, and I will get this all tied up and bundled up nice, but after that we should be set. Alright, so we've got the Renogy battery now fully installed. If you look at the controller, we've got a couple blinking lights. The PV is the solar panels. It's all good. The green flashing battery is saying that the battery's fully charged. And the other green is saying that, hey, it's detected the battery. So we are in good shape. Now what we're going to do is connect this, and we should be seeing bubbles. So we've clicked on the battery. We're on the inverter. We've got everything connected. You can hear it's not very loud. That pump's not very loud at all. And what you're starting to see is we now have bubbles. So we're going to let this run overnight, and we're going to see how it performs. Alright, day 2. We've got the new Renogy battery in here. and we ran our first overnight test with the Renogy battery. And actually it was probably the most adverse test because we put the battery in around 5:30 p.m. so not a lot of sunlight left to keep that battery charged. But as you can see out on the pond, it is still aerating as it should. Now we're going to take a quick look at the controller, and what you see, like what we should see on that Wanderer controller, you see the blinking green light, which tells us that the panels are working, and you see the solid green light on the battery, and what that tells us is we are charging the battery. So if that battery was full, that battery would be blinking green, which I would expect to see this afternoon sometime. But the key thing we found here is that this battery is capable of delivering overnight, and I expect this to be a 24/7 operation.
We've completed our day 2 test. I wanted to close out by, there are a couple of things to consider with regards to installing your solar powered aeration system. So one is age of the pond. And why is that important? The age of the pond kind of gives you an idea how much muck, etc., that could be in the bottom of that pond. And when we would go up into the pond, whether it be my dog swimming in the pond or if we did any work, you would smell just a god-awful, noxious smell coming from the pond. So we knew we had a problem. We also had problems with algae growth, etc. I ended up putting in 3 grass carp into this pond, but it still wasn't having much of an impact, and that was 3 years ago. So that was another thing. So then the other consideration is pond size and how much cubic feet of water you have. And so how I estimated cubic feet for the pond was I leveraged Google Maps. It's got a little legend down on the right hand side when you go in, put in your address, find your pond, and you can start to estimate, length, width, etc. And then what you have to do is there's some calculators out there on the internet, and you put in what your average depth was. And the max depth of our pond is also important with regards to, it's all about how much displacement of air that your pump can handle. So that's a pretty important thing. I bought my pump based on previous owners in my discussion that he thought that the pond was 12 to 14 feet deep, but he had never measured it. So what we had done is I went with the 12 feet, and miraculously the pump's at 12 feet, and it's performing so well that I believe that pump I could probably even put on a second diffuser. And the diffuser I have on there right now is a Metalla double diffuser. I could probably put a splitter on and probably put on another single Metalla diffuser just to get that extra aeration system. I don't believe I'm going to do that because I think I'm going to get enough, but I'm just trying to reiterate how well it's performing. A couple of key learnings are my dumbass moments. I went on the cheap side. I bought, as I mentioned earlier, I bought a couple of Harbor Freight solar batteries, 35 amp hours, and they did not perform very well. One ended up dying after 2 years. I had it on trickle charger since I've owned it, and it's never performed. And the other one, just not enough horsepower. So I spent the extra money on the second bout, and call it my dumbass learning for you folks is I went with the Renogy, and I went with the Renogy hybrid gel-based battery. And the reason I went with that was, and there were a couple others I think I could have gotten cheaper. I think Universal's was $179 gel-based 100 amp hour battery, but I decided I already went cheap once. I'm just going to buy this one solution. I want to make sure it works, and so I went with Renogy, which was the same brand as everything else I had, and it's working. So I'll let you decide that. What else? I bought 100 foot of hose. I would buy 100 foot of hose again. I'm very happy with the Renogy solar panels and their systems and how everything connects together. It just works great. So hope you enjoyed the video, and this is Two Dumbasses signing off. Be safe, have fun, and get outdoors.
Thanks for listening or watching our show. We have some exciting topics and guests coming up.
We ask that you subscribe to our channel on YouTube and follow us on Twitter, Instagram, and Facebook.
We look forward to hearing your suggestions for topics,
Questions and comments. This is Two Dumbasses signing off. Until next time,
be safe,
have fun, and get outdoors.